Hi everyone, hope everybody is doing great. Okay, in this video I want to go over hypothesis testing and testing one population parameter. But before that, let's talk about hypothesis testing. And in this video, I'm going to just show you how you can set up a hypothesis testing problem. So please follow the steps. I put those in 2 steps for you. Learn how to set it up. Then there's some theory involved behind that, and I'll talk about the theory in other videos. But in this video, just learn how to set it up. And sometimes there are a lot of questions why we do that. But please just follow, set it up. Once you know the technique of setting up a hypothesis problem and solving, then you'll understand the theory behind that. I think that way is better. Now, what is hypothesis testing? Hypothesis testing is testing a claim. So, what is a claim? So, let me give you an example. For example, the claim about the defendant entering a court of law is not guilty until proven guilty. So what they do, the defendant goes into the court of law and their evidences, those are the testing. And they test and jury decides if the defendant is guilty or not guilty. Is that decision always true or 100% right? No. But when you test it, there's some percentages, maybe 90% of the time it's right or maybe it's wrong. It makes the same way in statistics. But the question is what we can test and what are the claims about. So let's go over that. As we all know by now, in statistics, we have sample and we have population. The sample means X bar, sample standard deviation is S, and sample proportion is P hat. Then we have the population. The mean of the population is mu. The standard deviation, ST stands for standard deviation, is sigma, and the population proportion is P. And we know that when we did estimation. Now, sample is pretty straightforward. If you have a sample, you can calculate those or the sample statistics. Population is not very obvious. Sometimes you deal with millions of people, so or thousands of people. So calculating it is not very easy and it's costful. So what we learned before, we said we estimate those. The population parameters, sometimes if the population is not very big, then we can calculate. If it's big, then we estimate. Or we make a claim about and we test it. And that's what we're going to do in this video. So an example of a claim in statistics. So we can make a claim, as I told you, about the mean population standard deviation, and population proportion. Always population. You don't make claims about the sample statistics because you can calculate those. So, or testing, if you make a claim, testing it is just to calculate and you directly get the answer. But here the answer might not be 100% true when you test it. An example, the Coke company says the mean amount of Coke in cans of Coke or in a can of Coke is 12 ounces. We see that when you look at a can, it says 12 ounces. 12 ounces. Is that true? So now, if you are a statistician and you want to test that claim, you can't go and open every single can of Coke and measure it to see if it's 12 ounces. And I'm sure you already know the way you can test that is to pick a random sample and then do testing from there. Now, there's some steps to solve a hypothesis testing problem. So let me go over those. and we're going to go over each step. I have all the steps here for you and kind of go over them with some examples, but this is only the first video. I don't want this to be very long, so listen to this one, and in the next video we can solve examples. When you read a hypothesis testing problem, write the claim. That's the first thing you want to do. Write the claim that needs to be tested. That claim can be about P, can be about mu, and can be about sigma. Then decide if the claim is HO or H1. H1 is the same thing as HA. So HO or H1, I use the notation H1, but some books they use HA. Why we do that? Because HO is the null hypothesis, and H1 or HA is called the alternative hypothesis. These two are complements of each other. HO is always presented by these signs: equal, less than or equal, greater than or equal, and less than or equal. Alternative hypothesis, H1 is presented by these three signs: not equal, less than, or greater than. Be very careful when you see these signs, you know you're dealing with alternative hypothesis. And one more note that's very important. Even when you write the claim and it says less than or equal, greater than or equal to, or less than or equal to, once you finish writing HO and H1, change the sign of HO to equal. Why? We'll go over that later. Just right now, learn how to do that. I put the note for you here. Always change the sign of HO to equal sign. Then step number 3, we have OC, which is the original claim. That's the claim in the problem, the claim that you first wrote, or you write. That's called the original claim, and let's put OC for that. And CC is the counterclaim, is the opposite, or you can say the complement of the original claim. Now let's do some examples about these 3 steps, then we can go over step 4, 5, 6, and 7. And I think I have the exam. Yeah, there we go. The mean amount of Coke in a can or in cans of Coke is 12 ounces. So again, when I start writing that claim, so I can even erase those and start from the beginning so you can see. So let's follow step number 1. It says write the claim. So mu equals to 12. Let me start from scratch so you can see. Mu equals to 12. So all I did, I wrote the claim. Then I check the sign here. The sign is equal to. So as you remember, if I go to step number 1 or number 2, if it equals, then we know it's HO. So here I put HO colon mu equals to 12. Then you can write H1 now, and I'm going to start calling this H1 instead of HA. So mu is not equal to 12. We have our HO and we have our H1. Now we want to know which one is the original claim. The original claim is the claim I wrote first, the claim in the problem. So I put OC here, and this one is going to be CC. So HO is the original claim in this case, and H1 is the counterclaim. Let's do a second example. The mean amount of Coke in the can of Coke is at least 12 ounces. So if we start writing the claim, I can erase this. At least, that means the mu is greater than or equal to 12. So right away, I see the equal sign and I know this is HO. So I write H1, the mean is less than 12, the complement. Which claim I wrote first was HO, so this is OC and this is CC. Do not forget this part. As I mentioned, and I do want to show that note to you, I go up and down, but I think it's better. So the note I put here, always change the sign of HO to equal. So if we go back, for example, here I finished that, but I changed the sign to equal. One reason is because the population mean it's just one solid number, so that's it. That's why HO you just say equal to 12 ounces. So this is our final answer. Now a couple of things when you present the claims, the top right HO and the bottom claim has to be H1 all the time. So that's how books present those claims. So please have HO on the top, H1 in the bottom. Another example, the mean amount of Coke in a can is at most 12 ounces. And this one I can just go ahead and write it. So I write mu is less than or equal to 12 ounces. I have the equal sign here, so I know that's HO. Then H1, I write the complement of that, mu is greater than 12. The claim that I wrote first was OC, and then the other claim, the second claim, of course, is CC, which is the counterclaim. Do not forget the final answer. You change this sign of HO to equal, and that's how HO has to be presented, always with an equal sign. So this is our final answer. So another example, the mean amount of Coke in a can is less than 12 ounces. Be very careful with this one. And I think it's a good idea if I erase that and just rewrite it for you so you can follow. Is less than, so I'm going to say mu is less than 12. Less than 12, I don't have an equal sign. So if I don't have an equal sign, let's go back to our steps. If there is no equal sign, you know that's H1. So you don't always write HO first. So here, this is H1 now. So I'm ready to write HO. For HO, in this case, don't put greater equal to and then change it to equal. You can directly just put equals to 12. The claim we wrote first was H1, so this is OC and that's CC. Next example, the mean amount of Coke in a can is more than 12. So again, if we write that, I'm not going to erase this, but you just write that first, is more than 12. There is no equal sign, so therefore that's H1. And HO right away, you put the mean equals to 12. So H1 in this case is the original claim because we wrote that first from the problem. And of course, HO becomes the counterclaim. Another example, more than 90% of students love statistics. So be very careful. This claim is not about the population mean anymore. It's about the population proportion. So if you write that claim, let me erase and just write this. So I write the proportion is greater than 0.9, more than, no equal sign. If there is no equal sign, I know this is H1. So HO will be P equals to 0.9. I wrote this claim first. So this is the original claim, and that's the counterclaim. So HO is the counterclaim, is this in this case. So now let me go to step number 4, because those 3 steps I think you can, by watching this, you can handle it. Step number 4, type of test. To see what type of test we are dealing with, you always look at the sign of H1. So now let's go over this. If the sign of H1 is not equal to, then you're dealing with two-tailed test. You can draw this graph. Two-tail, that means you have a right tail and a left tail. If the sign of H1 is less than, then you're dealing with a left tail test. If the sign of H1 is more than or greater than, then you're dealing with a right tail test. So let's continue our examples. Less than number 7, less than 60% of students dance. So let's write the claim. If I write the claim, I write P is less than 0.6. That's the first thing you do. You write the claim. There is no equal sign, therefore this is H1. So you can write HO now. HO, just go directly and say P equals to 0.6. The claim we wrote first was the original claim, and of course HO is the counterclaim. We check the sign of H1 and it's less than, so you know this is going to be not two-tailed, but it's a left tail test. You don't have to put LT, but if you just draw it later on, you're going to see how useful is this. And then just shade the left tail. So this is a left tail test. Next one, the true mean is not 20. Whenever you hear the word true, just know that you're dealing with population. The true mean, that means the population mean. The true mean is not 20. So the true mean is not 20, you write that. You know it's not equal to, so it's H1. And HO will be the mean equals to 20. I wrote that claim first, so this is the original claim. And of course, the other one will be the counterclaim. Not equal to, we're dealing with a two-tailed test. So, and it's a very good idea to draw again the curve. And then here shade both sides. And it's TT means two-tailed. You don't have to write this. And we'll see later on why. Little note here, we're gonna find the critical values. That's gonna be the next step. The true, number 9, the true standard deviation is less than 5. This is a claim about the population standard deviation. It's less than 5, so you write that first. No equal sign, therefore that's H1. So HO will be mu equals to 5. I wrote that claim first, so that's my original claim, and then HO will be my counterclaim. Less than, I know I'm going to have a left tail test. However, be careful. When we deal with standard deviation, that means we're going to be dealing with chi-square distribution. As you know all, when we went over chi-square distribution, that's not symmetric. So draw the curve and just shade the left side of the curve. We are going to learn how to get all those values, the critical values. So now let me go to the next step. Step number 5, given alpha, the significance level. Alpha, I went over this on the last video, is the significance level. Basically, is the area in the tail or in the tails. So knowing that, find the critical values. Now, here, let me go over these 3 steps. If the claim is about P, that means population proportion, then you're dealing with a z-test. Z-test, that means the critical values are z-values or z-scores. And if you're using our calculator, we can use inverse norm to find those critical values. If the test is about mu, then there are 2 cases. We use z-test if sigma is known, just like estimation. So if you did estimation, then you should be familiar with that. So it's a z-test if sigma is known, and it's a t-test if sigma is unknown. So I can put this note for you. In this case, if you want to find the critical values, you use inverse norm. And here, if you want to find the critical values, you use inverse t with your calculators. Finally, if the test is about sigma, that's going to be a chi-square test, and you need to read those chi-square tests from the table, or you can download the program and use your calculators for that too. But we learned how to read the table, and it's pretty straightforward. So let's go over some examples of finding the critical values. So the first one, 95% of students study 20 hours every day. So alpha is given to be 0.05. First thing you do, you write the claim. So steps have not changed. P equals to 0.95. I have the equal sign, so I know that's my HO. So H1 in this case is going to be the complement of that. So you write P is not equal to 0.95. I wrote that claim first. So that's my OC, or the original claim. And of course, the second claim is going to be the counterclaim. Alpha is given, and we know that's a two-tailed test because the sign is not equal to. Alpha is the area in the tail. However, when it's a two-tailed test, you always divide alpha by 2 because you want to know this area in order to find that critical value. So 0.05 divided by 2 is 0.025. With your calculator, you can do inverse norm 0.05, 0, 1. Again, these are z-scores. The mean is always 0 and the standard deviation is 1. And if you do that, you get negative 1.96. If this is negative 1.96, then that will be positive now, 1.96. One thing also I want to note, whenever alpha is given in a problem, that's the significance level, you know that you're dealing with a hypothesis testing problem. Whenever the confidence level is given, like 90%, 95%, you know that you're dealing with an estimation problem. So it's very important to know the difference. Alpha given, it's a hypothesis problem, and alpha and confidence level given, you know it's an estimation problem. If alpha is not given in any problem, the most common one is 0.05. So just 0.05, that's the significance level. I will go over the details of significance levels, so kind of what they mean. Once we solve some problems, then these are going to be they're going to make a lot of sense. But right now, we're getting very close to the setup. Another example, the true mean is less than 15. Alpha is given to be 0.1, N is 20, and S is 6. Now, whenever I see S is given, that's very important too. That means sigma is not known. If sigma is not known and S is given, you are gonna use T distribution. So this is a T test, number one. But let's write the claim. The mean is less than 15. So I put less than 15 here. No equal sign, I know that's H1. I wrote that first, so that's my original claim. So HO is going to be mean equals to 15. And of course, that will be the counterclaim. Since we are dealing with T distribution, because S is given, we have to know the degrees of freedom. DF is n minus 1, which is 19. In this case, it's less than, so it's a left tail test. Only one tail. Do not divide alpha by 2 because it's a single tail test. Do not forget that test, that note. So how do I find this number? Again, for T, you can use your calculator. You go to inverse T, 0.1 degrees of freedom 19, and you get negative 1.33. So, and if the claim is about the standard deviation, then of course you use chi-squared and you find the critical value by using the table. I will show that to you in the examples. So now there's some more steps. I want to go over those, and then we can, in the next video, we can solve some examples. Next step, step number 6, is calculating the test statistics. Note the test statistics are formulas. If the claim is about the population proportion, it's a z-test. So the test statistics is a z-value. And the formula is given by p hat minus p over square root of p times q over n. And that p is the same thing as that. And we all know q is 1 minus p always. So please note that this P is in the claim, and that's the sample proportion. In the claim, for example, if I go here in one of the examples, it was about population proportion. In the claim, that's what I'm talking about. So this is for the formula if this claim is about population proportion, and just hang in there, we'll do a lot of examples. If the claim is about mu or population mean, you do z-test, and the formula is x bar minus mu over sigma over square root of n if sigma is known. So you use that, and it's a z-value, and this is in the claim. Then if s is given or sigma is not known, then it's a t-value. That's x bar minus mu over s over square root of n, and as always, this is in the claim. Finally, if it's the claim is about sigma or population standard deviation or even the variance, then it's a chi-square test, and the test statistics is chi-squared equals to n minus 1 times s squared over sigma squared, and that's in the claim. Step number 7 is the conclusion. So now we're gonna learn about p-value. Once I do examples, I'm gonna tell you. But just remember, when you calculate the test statistics, any of those formulas, when those formulas are in the shaded area, so for example, this is 1.96, that's the critical value, and the test statistics is in the shaded area. So this is the test statistics. And let's say that number is 2.5. That means we are in the shaded area. Shaded area, that means this continues. So test statistics falls in the shaded area because it's greater than the critical value. Then you say reject HO. If the test statistics is in non-shaded area, that means you calculate it in somewhere here, non-shaded area, or the p-value is less than alpha, and again, this number, this area is alpha, and p-value is less than alpha, then you say fail to reject HO. Shaded area, reject HO. Non-shaded area, fail to reject HO. Just remember it, and I'll talk about those during the when I do examples, more examples for you. What is p-value? Just to give you an idea of what p-value is. So if this is our alpha and this is our test statistics, alpha is the area in this tail. P-value is the area after the red area, the test statistics. So you kind of compare the red area to the black area, which is right here again. If the red area is greater than the black area, then you fail to reject HO, just this, like this case. If it's less than or if it's inside, then you reject HO. And one more time, this is p-value, which is the probability value, and this black area here is alpha. In this case, the p-value is greater than alpha, so the conclusion would be fail to reject HO. Or you can clearly see the test statistics is in the non-shaded area. So again, the conclusion will be fail to reject HO. So, and step number 8 is the main conclusion. In the next video, I will do some examples, and these are going to make a lot of sense. I think that's good enough for this video. Please watch this at least 3 times. And once this makes sense, then once I do the examples, you're going to understand them much better. Hope everyone will have a great day, and I'll see you very soon.